This is a presentation of Chapter 1, Section 11 in the 7th grade textbook entitled Solving Equations by Multiplying or Dividing. We begin just as we did in 110 with the different properties that we will employ in solving here today. The multiplication property of equality that says the property that states that if you multiply both sides of an equation by the same number, the new equation will have the same solution. That's the property that states that if you multiply both sides of an equation by the same number, the new equation will have the same solution. And that's the property we're going to use to solve division problems. Division property of equality, that's the property that states that if you divide both sides of an equation by the same non-zero number, the new equation will have the same solution. That's the property that states that if you divide both sides of an equation by the same non-zero number, the new equation will have the same solution. And that's how we're going to solve multiplication problems. Now, the techniques you're going to see employed here in 111 are identical to 110. All those rules that you heard me talk about in 110, they all still apply. The only difference is between 110 and 111, 110 was all about adding and subtracting. 111 is all about multiplying or dividing. And that's really the only discernible difference between these two sections. We're still going to use all those rules. So we're still going to keep our variables to the left of the equal sign. We're going to send all of our numbers to the right side of the equal sign. We can flip the sides around whenever we need to, and whenever I want to move something to the opposite side of the equal sign, or the other side of the equal sign, I'm going to do the opposite. So let's go ahead and take a look at what we've got here for examples. The first one's asking me to solve the equation h divided by 2 equals 13. Check your answer. Now, remember, when it's got the fraction bar like that, a fraction bar is just a giant division problem. So that's why I'm saying h divided by 2 equals 13. Well, let's go through our little checklist that we went through yesterday. We know we want to keep variables on the left side of the equal sign. So variable h is in a good spot. And the number 13 there, he's also in a good spot because numbers belong to the right side of the equal sign. So the only thing that needs to move here is the 2. The 2's got to move to the other side. Well, notice right now that this question is saying that I'm dividing by 2. Well, the opposite, which is, remember, how we move something to the other side, the opposite of dividing by 2 is to multiply by 2. So as you can see, there's some giant parentheses here, and I'm showing that I'm multiplying both sides by 2. Those giant parentheses are the proper and correct way to show that you're multiplying. It's not really proper to come underneath, like with addition and subtraction, and do something like this. Right? The correct way to do it is what you already see on the screen, to show that you're multiplying both sides by 2 by using parentheses. And you can put the parentheses around the number you're multiplying by, or you can just put them around what's already there and put the 2's on the outside. Either way is good. So over here, this divide by 2, multiply by 2, those cancel each other out, just like the addition and subtracting did yesterday. So that's just going to leave me variable h. And over here, I've got 13 times 2, which is 26. So this is implying that h is 26. Well, down here, they're checking it by now changing h into 26. Remember, the way we check an equation is to plug in the number and then make sure that what it says on the left side is the same thing as what it says on the right side. So we've got 26 divided by 2 here, which is 13. The other side says 13 as well. Since both sides say 13, we check, and that means that we solved the equation correctly. h is 26. Here's 51 equals 17x, and we're supposed to solve and check our answer. Now, this is the first time in 110 and 111 combined that we've ever been presented, at least in the notes, with the variable being on the wrong side of the equal sign. Remember, I said in the beginning that we want our variables on the left, but clearly x is on the right side of the equal sign. We don't want that. So what we're going to do here to start is we're going to flip the sides. And that's what we've said a bunch of times now, but we've never actually used it in the notes. Well, now you get to use it. I'm literally going to invert the left and the right side. and I'm going to make this say 17 times x equals 51. You can do that at any point along the way solving equations that you might need to. You could do it in the middle of solving if it suits you, in the beginning of solving, right at the end. Whenever you need to, you can flip the sides. But notice by flipping the sides here, look at all the good stuff that happened. I've got a variable x on the left side of the equal sign. And I've got the number 51, again a number, on the right side of the equal sign. So the only troublemaker in this whole mix is the 17. So I'm going to have to move him out of the way. Well, notice this question says right now that I'm multiplying by 17. So I'm going to do the opposite, which is to divide by 17. Which is exactly what they're showing you here in their work. It's just they didn't do the flip step. Well, the 17 divided by 17, those cancel each other out and just leaves me variable x. Or if you want to think of it as 1x, 1 times x, you can do that as well. On the right side, we've got 51 divided by 7, 51 divided by 17 rather, 51 divided by 17 is 3. So the suggestion is that x equals 3. Well, let's go back up and check. The left side says 51. This would be 17 times 3, which is what they're showing you down here, which is also 51. Since the left and the right side both say 51, that means we correctly solve the equation. Here's number 3, a word problem. It says Trevor's heart rate is 78 beats per minute. How many times does his heart beat in 10 seconds? So obviously, this has somehow got to be about writing an equation because this section is all about solving equations. So we're going to take that, what they says there, and write an equation from it. We're going to write an equation where B, they just chose B at random, is the number of heartbeats in 10 seconds. Well, if we count our heartbeats in 10 seconds and then multiply by 6, because there's 60 seconds in 10 seconds in a minute full of time, or 6 10-second intervals in a minute, all right, that's going to help me find my heart rate in beats per minute. Again, why? 10 seconds is the time we found. If we multiply that by 6, that's 60 seconds. 60 seconds is a full minute. So the number of beats in 10 seconds, B, being multiplied by 6, gives me my beats per minute, which in this case says in the first sentence, 78. It says heart rate is 78 beats per minute. So we're going to solve the equation B times 6 equals 78. All right, so I want my variables on the left, which I do have a variable B on the left side of the equal sign, and I want my numbers on the right. Well, I do have the number 78 to the right side of the equal sign. So the guy that's in trouble here is the 6. I'm going to have to get the 6 out of the way here. I'm going to divide both sides by 6. So I chop 6 out on both sides. 6's cancel out and just leaves me B. Again, that's what should happen every time. Somehow, you should always just be left with the variable on that left side when you're at your final step. On the right side, 78 divided by 6 gives me 13, and so Trevor's heart beats 13 times in 10 seconds. We can check it if we want to. We can go back to here and change this into 13. 6 times 13 is 78. Since the other side says 78 as well, my equation checks. My answer must be correct. So in number 1 here, they're asking us to solve the equation x divided by 5 equals 30. Well, again, we want to keep that variable on the left side. So x being on the left is a good thing. And we want to keep 30 on the right side because numbers belong on the right side. So the only guy that's in the wrong spot is the 5, because he's a number and he's on the left, but he's supposed to be on the right. Remember, when I want to move something to the opposite side, as in the opposite side of the equation to the other side of the equal sign, I'm going to do the opposite. Well, right now this says I'm dividing by 5. So the opposite would imply that I'm multiplying by 5. So I'm going to put some giant parentheses down here and show that I'm multiplying both sides by 5. So I've got 30 times 5 there. That's 150. I'm just left with x here because dividing by 5 and multiplying by 5 wipes each other out. X must be 150. We can check it. 150 divided by 5 is 30. Since the other side says 30, we know we must be doing this correctly. Solving 76 equals 19y. Well, we don't like that so much because that's written in the wrong order, like the question we saw earlier. So we're probably going to invert this whole equation, flip the left and the right side, so it says 19y equals 76. Well, that's a multiplication equation, which I'm now going to solve by dividing. Dividing both sides by, in this case, 19. Why? Well, we've got a variable on the left, that's good, and 76 on the right, numbers belong on the right. So the only guy that's out of place is 19. He's a number, he's supposed to be on the right, but he's on the left. I'm going to move it by doing the opposite because that's always how I move things here. And so since this is a multiplication question, multiplying by 19, the opposite would be to divide by 19. When I do 76 divided by 19, I get 4. Over here, the 19s cancel each other out and just leaves me my variable. Again, that's always our objective, is to get that variable by itself on the left side. We can check it. 19 times 4 is 76. Since both sides say 76, both sides are the same, that means the equation checks and we've solved this correctly. All right, finally here's question 3. During a stock car race, one driver is able to complete 68 laps in an hour. How many laps would he finish in 15 minutes? So, what we note here in the first line is actually just not me solving the equation, but some steps that I need. I recognize that there's 4 15-minute segments in what the driver did on the track. There's 4 15-minute segments in the full hour that he was on the track. So my equation says x times 4 is got to be 68. Again, because there's 4 15-minute segments, 4 times how many ever laps he did in each one of those segments would equal 68. So, taking a look at that equation that I just wrote then, keep my variable on the left. Well, I do have x there, that's good. Keep my number 68 on the right, because numbers belong on the right. So the one thing that's out of place is 4. He's a number, he's on the left, but he belongs on the right. So, I'm going to get rid of him by doing the opposite. Right now this says I'm multiplying by 4. So the opposite is going to be to divide both sides by 4. When I do 68 divided by 4, I get 17. So that means he must have done 17 laps in 15 minutes in context of the question. We can check it by going back and changing x into 17. 17 times 4 is 68. Since the other side says 68, the equation checks. Our solution must be valid.